Hi everyone and welcome to the ACE Academy Grade 10 Functions video series. In this series of short videos, you will learn everything that you need to know with regards to Grade 10 functions and how to apply yourself in the examination when it comes to this section. A really important point to take note of from now is the fact that functions is one of the major sections in your matric final exam. This makes up 50 marks out of 150 in your grade 12 NSC final paper 1. Hey, that is a solid chunk of marks. Now, like any section, I like to start off by giving you guys a little roadmap of what to expect when attempting a section like this, because if you guys don't understand what you're working towards, you're not going to value the information that is being given to you. You need to understand what you're working towards in order to grasp it correctly. With that being said, what we have here is a list of prerequisite knowledge that you guys will need before attempting this section. What I mean by that is, if you guys are not strong in these sections in mathematics, if you don't have a strong skill set with these specific topics, you're not going to understand functions well. This is because these sections in mathematics are present in functions. If you're not going to be able to grasp it and apply it, you are definitely going to struggle. So my suggestion for you guys is, if you feel like you are not confident in your mathematical skills with regards to the sections, go back, watch another video regarding these sections, and get yourself ready for this one specifically, okay? Now, on this list, we have some basic algebra skills that you guys will need, and that consists of your laws of exponents, the ability to solve equations, both linear and quadratic equations. That's really important. And you guys are going to need to be able to factorize correctly, because factorization is key in this section. Now, the last one on this list is the Cartesian plane. And we're going to do that together, because I find that a lot of people take the Cartesian plane for granted, given that it is quite simple. But if you don't understand what the Cartesian plane is, you're not going to understand the point of this section. So we're just going to go ahead and do a quick overview of that to get you guys ready for the section, okay? Now, one of my first statements in this video was that I want to give you guys a roadmap to follow when attempting this section specifically. That being said, what I've done is I've compiled a list of 4 functions that you are going to be doing from now till matric. These are the same 4 functions that you're going to be doing. It's not going to be different in any way. We're just going to kick it up a notch as you progress in your grades. But the fundamentals remain the same, okay? Now, functions is the study of shapes, right? It's a bit like geometry, but it's more mathematically intense, more mathematically heavy. We're going to focus more on the mathematics than the shape itself, but we are going to relate the two together. Now, on the screen right now, you guys can see 4 shapes that are in red. We start off with the linear function, which is basically a straight line at some angle. We then have the quadratic or the parabolic function, which looks like a smiley face, or it can look like a sad face depending on what it is. And we have the hyperbolic function and the exponential function as well. Now, what we're going to do with these functions is we're going to study its shape heavily. We're going to manipulate the way these functions look. In terms of the linear function, we're going to change its slope. We're going to make it more steeper. We're going to make it less steep. Stuff like that. We're going to change the type of gradient that it has. When it comes to the parabolic or the quadratic function, we're going to flip it over. We're going to change it from a smiley face to a sad face. We're going to widen it and we're going to squeeze it. In terms of the hyperbolic function, we're going to change the quadrants in which it lies. So from the first and the third, we're going to change it to the second and the fourth. And don't worry about that big word just yet, quadrants. We'll go more into it as we go along with the series, of course. And then we have the exponential function, which is a single curve. We're going to flip the quadrants in which it lies. So right now you can see it lies in the second and the first quadrant. We're going to make it lie in the third and the fourth quadrant. We might be able to increase its size and stuff like that. Those are just simple manipulations that you're going to learn in this series. Along with that, we're also going to manipulate these functions in such a way that we are going to we're going to move it up and we're going to move it down. It's as simple as that. It's called a vertical shift. So we're going to see how we can relate the equations of each one of these functions and manipulate it using the equation and understand the shape. We're also going to learn how to sketch these functions. That's really important. If you don't know how to sketch these functions, it's not going to be easy on us, of course. So we have to learn how to sketch these functions. We're going to learn about the properties that each function has, and we're going to apply it in terms of examinable questions. Right, so moving on, we are going to look at the Cartesian plane. Now what you can see on screen at the moment is a simple Cartesian plane which consists of an x-axis on the horizontal dimensions and a y-axis on the vertical dimensions, right? What I've done is I've placed two shapes on this Cartesian plane as well. I've placed a rectangle and a triangle, and we're going to work with this together. Now, the first thing that I want you guys to understand when it comes to a Cartesian plane is that this is merely a tool that we use as mathematicians to analyze shapes and convert them into numbers. It's a translating tool. You know, like Google Translate, Afrikaans to English, English to Afrikaans, English to isiZulu, isiZulu to English, stuff like that. Yeah, this is essentially what this tool is for us in maths. We are going to use this as a method of translating pictorial data, pictures, into numerical data that we can use in equations. Okay, and so what I want you to do is give you guys a little bit of an analytical geometry introduction so that you understand it a bit better, and we are going to go into the functions part of it a little later, right? Now, the first thing that I want you guys to notice is that these are 2D shapes. They have two dimensions. They have a length and they have a height. I'm speaking in terms of length and height here just to make it a bit easier to understand, right? Now, the way we're going to measure the length of these objects is going to be on the x-axis, right? That's our horizontal value. The length of these objects are the horizontal values of these objects, right? And the breadth or the height of these objects are going to be along the y-axis, is going to be a vertical value. All right, so what I'm going to do quickly for you guys is I'm going to define each one of these points, and then we're going to work with it. Okay, and boom, these points are now defined for us, just like that. Okay, now we're going to look at the rectangle and we're going to define these things numerically according to the labels that have been given on the rectangle. So we're going to look at the point A, which is a corner on the rectangle. Now, the way that we define these points, or these corners in this case, is going to be from a reference point that is located here at the center of the Cartesian plane. That is where the x-axis and the y-axis cut each other. And that point is known as the origin, and it has the values 0, 0. That's its coordinates. Now, when we're talking about coordinates, right, this is where coordinates come into being. A coordinate is a lot like latitude and longitude. In fact, it is latitude and longitude in a geography perspective. But in terms of coordinates, right, a coordinate is essentially we giving it a length and a height value. Now, the way we're going to measure this is going to be with accordance to a reference, which is called the origin, and it's located where the y-axis cuts the x-axis, and that coordinate is going to be 0, 0. It's our reference point. So let's go ahead and give the coordinate for the point A. Now, what we're going to do is we're going to draw a vertical line from point A straight down, perfect 90 degrees. It's going to come down, it's going to come down, it's going to come down. And let's imagine it cuts through the 1 there. I don't think my slides are perfect, but let's just imagine it cuts through the 1. So this vertical line that we've drawn, right, it's cutting through the value 1 on the x-axis, the x value 1. Which means point A is exactly 1 unit to the right of the origin. And that is the value that we're going to label first. Okay, that is our x value. Now, for any point to be defined, it needs two values on the Cartesian plane. So what we're going to do is we're going to draw a nice little horizontal line from the A point, and it's going to cut through the y-axis. And the point at which it cuts through the y-axis is y value of 5. So we're going to just put it down here neatly on the side. That's not that neat, but I mean, you get the picture, right? Okay, and essentially what we've gotten here is a coordinate. Now when I'm talking about y value 5, that point at which A is 5 units upwards from the origin, 5 units up from the point 0, 0 on the y-axis. So just to double check it, right? Just to double check it, what I'm going to do is I'm going to use my coordinate system over here, and I'm going to use it to locate point A without even looking at it. Okay, let's read this thing correctly. So if we're looking for x value 1, we're going to go to the Cartesian plane. We're going to look for 1 on the x-axis, and we're going to look for the vertical line that goes upwards, right? Then we're going to look for y value 5, and we can see that at the y value 5 and x value 1, we are going to find point A. It's a location 2. We just converted from a pictorial bit of data to a numerical bit of data. And now what we're going to do is we're going to do this for all 4 points. So let's go ahead and define this rectangle in terms of coordinates, numerical data, so that we can work with it, right? For point B, if we're looking for its x value, vertical line down from point B cuts to the x-axis at x is equals 3. So we're going to put that first. Then we're going to look for its y value. Let's go through for the horizontal line, and that cuts your y-axis at y is equal to 5. If we're looking at point C, that is at x value of 3. And a y value of 2. If we're looking for point D, that would be at x value 1 and a y value of 2. Now let's work with this triangle that we have over here. Now we're going to do the exact same thing, so if you'd like, you can pause the video and you can attempt it for yourself. But it's not all that different. We're going to look for point E first. And point E lies on x value of -5. And a y value of -1. If we're looking for point G, we're looking for x value of -2 and a y value of -1. And if we are looking for point F, we are looking for an x value of, let's just estimate it here quickly. I forgot to put in that line, my mistake. We are looking at an x value of -3.5. Can you see that it lies exactly halfway between -3 and -4? So that is -3.5 and a y value of -4. So this is quite intuitive, I hope. And it's that simple. That's how we work with a Cartesian plane, and we transfer or translate between pictorial data and numerical data and vice versa. Okay, now the next thing that I wanted to do with you guys is I want you guys to be able to mathematically define horizontal and vertical lines. Now this skill is important because it's going to assist you in understanding each one of these functions respectively, right? So we're going to look at the line A first, right? The line A is red, and it is a horizontal line that is cutting through the y-axis at y is equal to 4. This continues forever, which means for any x value that I have, my y value is still going to be 4. What does that mean, really? That means that the y value for this line is not dependent on the x value at all. It has a constant y value forever. Those arrowheads mean it continues forever, right? So if I wanted to define point A, I could simply do this by defining it as a y value because it only has a y value. And simply put, the equation for line A would be y is equal to 4. When it comes to line B, this is a vertical line. Now, a vertical line works, but it's quite similar to the horizontal line. It's quite similar to line A, but you'll notice that this yellow vertical line for B, it cuts through the x-axis, and it continues that way forever. It never goes to any other y point. It stays at the x value of -3. Because of that, I can define it as x is equal to -3. It's that simple. Now, if you guys would like, you can pause the video and attempt line C and D yourself. Alright, if you've done it already, that's great. If you haven't, it's okay, we're going to do it together. Now for point C, sorry, for line C, my mistake. For line C is a continuous horizontal line. It cuts through y value of -2. So I can indicate this with a simple denotation, a simple equation, y is equal to -2. And if I'm looking at line D, which is the blue line, it is a vertical line and it cuts through the x-axis as x is equal to 1. So its equation would be x is equal to 1. That's as simple as it gets when it comes to defining a vertical and horizontal line. Now, here's something that's really important. There are 2 more lines on this graph that we haven't yet defined with an equation, okay? And that is your x and your y axes. Now these lines actually have an equation for themselves. They are both of them are straight lines. The x-axis is a horizontal straight line and the y-axis is a purely vertical straight line. Now, just like how we defined these other horizontal and vertical lines, we can also define the x and the y-axis, and this can be done in the form of an equation. So we know that the x-axis is a horizontal line, right? So how do we define horizontal lines? We define horizontal lines in terms of the y-axis, because the y-axis is a vertical line and it cuts directly through the y-axis, so we can get a y value. Now for the x-axis, the equation is y is equal to 0. And with that being said, it should be quite simple to denote the or find the equation for the y-axis. Same process, it would be x is equal to 0. And it's that simple, guys. So if you found this video informative and if you felt like you learned something from it, I encourage you guys to go ahead and check out some of the other videos in this video series. I can assure you that it should help you in some way or the other. So until next time, all the best for your studies, and I hope to see you guys again.